Okay, part 4, Kramer's rule. I don't know what the word either is in there for. Use Kramer's rule to solve the system of equations. Kramer's rule is the rule we learned that involves finding determinants. Okay? Determinant D is the determinant of the coefficient matrix 1, 3, 5, negative 2. Determinant sub x is equal to a determinant where the x column has been replaced with these values here. So 3, negative 8, and then 5, negative 2. The determinant d sub y is a determinant in which the y column has been replaced with these values. So the y column becomes 3, negative 8. The x column stays 1, 3, as it originally appears here. And so the determinant of this is negative 2 minus 15. The determinant is negative 6 minus negative 40. Determinant here is negative 8 minus 9. That equals negative 17. This equals 34. This equals negative 17. Kramer's rule states that x is d sub x divided by d, and y is equal to d sub y divided by d. D sub x is 34 divided by negative 17, which is negative 2. This is negative 17 divided by negative 17, which is equal to 1. So the solution is negative 2, 1. It's never a bad idea, especially with smaller systems, a 2 by 2 system of equations, to check your answer. If x equals negative 2, this becomes a negative 6. And if y is equal to 1, this is minus 2. 6 minus 2 is equal to negative 8, so it checks out down there. If x is negative 2, that becomes negative 2. Negative 2 plus 5 is equal to 3, so it checks out there as well. Always check your work as best you can if you have time. Okay. Solve the systems by using an augmented matrix and reducing to row echelon form. This is a Gaussian elimination. It's sometimes a very time-consuming way, but the reason it's learned is this is how a computer system would solve a complex system of equations. Is a method similar to this. So we first need to write the augmented matrix. 4, 3, negative 2. Okay, first concern here is that this is not a 1. In order to reduce this to row echelon form, the leading term here of the top row needs to be a 1. So my first operation is going to be to take row 1 and times it by 1/4. Essentially that's going to divide row 1 by 4. That's going to become a new row 1. So row 1 is going to be 1, 2, negative 1, 1. Now that we have a leading term or leading entry here of 1, the entries beneath that leading entry need to be 0. So a row operation, if I take row 1 here, multiply it by 3, so 3 times row 1, that's going to put a 3 in that. Now if I subtract row 2, which also has a 3, 3 minus 3 is going to be a 0. Now I want the 0 to be in row 2, so I'm going to make this equal row 2. So 3 times row 1 minus row 2 is going to put a 0 here. 3 times row 1 makes that a 6. When you subtract 8, you get negative 2. 3 times row 1 is negative 3, minus 5 is negative 8. And 3 times row 1 is 3. 3 minus negative 11 is 14. Now we need to perform a similar operation to get this to be a 0, this entry right here. If I multiply row 1 by 2 and add row 3, 2 added with a negative 2 is going to result in a 0. So 2 times row 1 added to row 3 is going to equal row 3. It's going to be a 0. 2 times row 1 is 4. 4 plus this 1 is 5. 2 times row 1 is negative 2 plus 12 is 10. And then 2 times row 1 is 2. 2 plus negative 17 is negative 15. Now that we have a leading entry of 1 and zeros beneath that, we now look to the middle row here. This leading entry should be a 1. So if I take negative 1 half and times that by row 2, and have that equal row 2, negative 1 half is going to change this to a 1. If I times negative 2 by negative 1 half, that's going to result in a 1. So that middle row is going to become 0, 1, 4, and negative 7. Timesing by negative 1 half is the same as dividing by negative 2. Okay, now that I have a leading entry of 1 in that middle row, beneath that should be a 0. So if I multiply row 2 by 5 and subtract row 3, 5 minus 5 is going to be 0. So if I take 5 times row 2, subtract row 3, that's going to equal row 3. So row 3 is the row that's changing. So start there, 0. Now 5 times row 2 is 5. 5 minus 5 is 0. 5 times row 2 is here is 20. 20 minus 10 is 10. 5 times row 2 is negative 35. Negative 35 plus 15 is negative 20. And we can stop here now, even though this isn't truly row echelon form. This really should be a 1, but I think we can get the idea now. This bottom row is telling us that 10z is equal to negative 20, which means that z is equal to negative 2. Now if we go back up here, this row is telling us that y plus 4z is equal to negative 7. If z is negative 2, this says that y minus 8 is equal to negative 7, which means that y is equal to 1. Top row is telling us that x plus 2y minus z is equal to 1. Let me write this down here. The top row is saying that x plus 2y minus z is equal to 1. If y is equal to 1 and z is equal to negative 2, this turns into x plus 2 plus another 2 is equal to 1. 2 plus 2 is 4. When that's subtracted from 1, x is going to equal negative 3. So the solution is negative 3, comma 1, comma negative 2. And again, it wouldn't be a bad idea to make sure you've done things correctly. For example, if you take all these three values and plug them into the bottom equation, negative 2 times negative 3 is 6. Y is 1, so that's plus 1. Z is negative 2, so that's minus 24. 6 plus 1 is 7. 7 minus 24 is going to be negative 17. And if you were to check them, which you should, check them in the other two equations, it would turn out to be true as well. So that is our solution. The final exam, as you read on the directions to this review, the final exam is going to consist of about 10 of these questions off of this review and about 4 questions off of the review that I gave out from chapters 8 and 9.